Hello everybody! Welcome to Funtastic Academy with me, Ayush Prasad. Last video, we studied about adders, but we also recognized a serious problem in them. The ripple adder we built last episode had to wait for the entire sequence of carries to ripple down before it could output the data. But there's a way to solve this. In fact, that was our quiz question. How do we solve this? And the answer is by using a carry look-ahead adder. But what is a carry look-ahead adder? That's what the rest of this entire video is about. So strap your seatbelts, even though you're probably not in a car. I hope you're not listening to this while you're in a car. But anyway, strap your seatbelts and get ready to dive in. Unless you're in a car, in which case please don't. But dive in the wonderful world of carry look-ahead adders. Hello everyone, this is Computer Ayush here. The problem we mentioned in the last episode was that each full adder with 5 bits had to wait for the previous 5-bit full adder to complete its thing before doing its own calculation. That takes a lot of time. Modern computers have 64 bits of data, meaning in this case, we would have to wait for 320 gate calculations before getting our final output. And you can't just take half the output and be done halfway there, because it generates higher and higher, more important bits as it goes further along. So you have to wait for the full process to finish before running. Wouldn't it be nice if there was an easier way to do this? That's where the carry look-ahead adder or CLA comes in. To start, I'll make a circuit called a PG circuit. PG stands for propagate and generate. What does propagate and generate mean? There's 2 ways for bits to have a carry. One way is if the last bit was both ones. That would mean it outputs a 1, 0, and then it would get a carry of 1 on the next bit. The second way, if one of the bits are on, but the other's off. In that case, if the last bit had a carry, it will propagate that carry onwards. So if both bits are on, we can check that using an AND gate, then it generates a new carry. But if either of the bits are on, then we can say that this circuit will propagate whatever the carry from the previous circuit was. So we can just write this as generate, wire that up, and the circuit propagate. Now, this might seem like a really simple circuit because it's a really simple circuit, but it's actually really easy to build an adder from this. I'm going to build a 2-bit carry look-ahead adder or CLA. I'll just set up all the inputs. A1, B1, A2, B2, and the carry input Cin. We insert 2 full adders. We're going to put these back here. But we're also going to insert a PG circuit as a subcircuit. What we can do is calculate whether the first 2 bits will generate or propagate a carry. They can't propagate because there's nowhere before to propagate from. So the only way they could carry is if it generates a carry. We can plug that as a carry input. This allows us to extremely quickly calculate carries without having to deal about all this stuff about calculating the first full adder before. Nothing from this circuit will go into this circuit. After this, it's really simple to calculate the sums. We just plug in the right data in the right places. And with that, we have a carry look-ahead adder. If we generate a carry, that automatically goes into the next full adder without having to wait for the next carry input. The carry input is actually plugged in here. Now we just plug the outputs O1 and O2. Here our circuit is calculating 1 plus 1 plus 1 equals 3. If 1 plus 1 is equal to 2. But here's a problem. It says 3 plus 1 equals 0. It should be 4, but our circuit only has 2 bits. It can't store values greater than 3, so it can't store 4. We need a carry output. We could just plug Funtastic out here, but there's a much more deeper and interesting way of doing this. If there's a carry from the A2B2 digit pair, the only way that could happen is that if this pair generates a carry, or if it propagates a carry that this circuit generated. So we add yet another PG circuit. We feed in the values. And the carry out will be true either if this generates a carry or if it propagates a carry and the previous carrier generates a new carry for it to propagate. If I just write this up high, then it gives the right carry out, which we call carry out. And with this, we've fully made a carry look-ahead adder for 2 bits. It might seem more complicated than the ripple adder we built, but don't be scared because this is also both easy to understand and fast. This circuit, you can easily get the carries by just running all the PG circuits simultaneously and then running all the full adders simultaneously to get a much faster result. This carry look-ahead adder is at the heart of every computer in the world, and we just built one. So this is the machine that we'll be building upon in later episodes to add, subtract, multiply, divide, store, draw. Everything in our computer comes from this. The humble carry look-ahead adder. Thank you, and back to camera, Ayush. Thanks, computer Ayush. So, what did we learn today? We learned about carry look-ahead adders and how they can be implemented in the simulator we built. But what was the first actual practical implementation of a carry look-ahead adder in a computer? Send me the answer before next episode, and this is me, Ayush Prasad from the Funtastic Academy. Bye!